My topic is oil spill modeling and detection of oil slicks using SAR data, which is nothing but the synthetic aperture radar data. Here is outline of the presentation. Mainly, I will be covering these 4 key points. So they are, the first one is the operational system, what we have at our workplace, and how we are detecting the oil slicks with the help of the SAR data. Then what are the other models that are available in the scientific market? Maybe we can call that as next generation oil spill models. Lastly, I'll be telling about the research activity which we are carrying out in oil spill trajectory prediction and generation of geographical response plans. Here is the way we'll follow to do the trajectory prediction and validating that predictions. In the last session, there were some questions like how we are doing the prediction and validation. I believe here is the answer for your question. Here, if you notice, this is the core model which we use for doing the oil spill trajectory prediction, which is NOM. That model will be forced with the help of the metocean forcings, wind forcing, and the current forcings. So these are all the vital forcings that are used to drive this oil spill trajectory model. Once the user gives the preliminary information like the location of the spill, what's the date and time, how much quantity is spilled, and then what is the type of the spill. If you give the information, then the model will be forced to deliver the trajectory. So once after getting the trajectory, this will be compared with the field report as said by Commander P.K. Srivatsava in the last session, and also using the satellite data. So these, the simulated trajectory or the simulated drift pattern and the oil slick signature that is obtained from the satellite data. So both will be, taken to a common platform and both will be compared. I will show you some cases like how the comparison is done. And for all your information, this is we are already aware that we have launched our operational system during August 2016, which is an automated online oil spill advisory system, wherein the user need to give the preliminary information into the system. You can log into a system, and by giving the preliminary information, then you will be getting the trajectory. Our system is being utilized during real oil spills, hypothetical events, marine mock drills, pollution response exercise in national and regional levels, and also it's being used in research activities. Here if you see the users who are all using our services, ranging from Indian Coast Guard, and then environmental consultants, pollution control board, port and maritime officials, and then disaster management. So we have a wide range of users using our operational service. And here we go with a case study. This is a recent event that occurred during June 2022. Here we started giving advisories from this spill location from 21st of June onwards, because we got an information that the vessel got distressed at this particular location, and then in case of any oil spill, how it can go. So this prior information can help the oil spill responders to plan their response and cleanup operations. Here, once after generating the drift patterns, we have got the satellite data from European Space Agency, which is the radar data. Here in this image, you can see this plus symbol denotes the spill location, and you can see a snaking oil slick here, which is moving southwards initially, and then it is moving towards the coast. So these are all the signature that is obtained from the radar data, that is a synthetic aperture radar data from Sentinel satellite. this signature is used for comparing the simulated drift pattern. Here you can see these red dots which are all here. Those are all the simulated, means the predicted patterns from our model, this entire thing. And here you can see there is a good agreement between the simulation and the observed oil slick signature. And this one, and this, I will tell you just how you can detect the oil slicks from the synthetic aperture radar data. Here I have took a case study which was during July 2018 from the vessel SSL Kolkata. So here, once after getting the raw data set from the Sentinel-1 mission, you need to take it to the Sentinel application platform, which is software. And then after doing the radiometric calibration and terrain correction, you'll be getting the sigma naught plot. Sigma naught plot is nothing but the backscatter coefficient of that SAR data. From that one, you can identify the oil slick pixels, or oil slick signatures also you can detect. And here you can also estimate the dimension of the slick. In this picture, you can see, once after processing the data, I have exported that to GIS maps. So this blue and the red one showing the signatures that are obtained from the Sentinel data. So this, the blue one is on 17th of July, and the red one is of 15th of July. And here also you can, here you can measure the dimension of the slick also, which is being observed from the SAR data. Here you can see approximately around 9.84 kilometers on 15th and 9.09 kilometers on 17th of July. So these dimensions also you can compute with the help of the SAR data. And not only that, you can estimate the shift of the vessel from its datum. Here in this picture you can see the location of the vessel on 5th July 2018 is here, which is mentioned as a hollow circle, black circle. And this one, the plus symbol denotes the drifted position of the vessel after 10 days. So here you can see the vessel drifted towards north, approximately 1.43 kilometers from the datum, from the reference. So this type of information also you can get from the radar data. And there are other features also we can detect from the radar data. My successive speaker will speak more on that, because they are mostly working on this radar and satellite data processing. And now I will move on to the next generation oil spill modeling. Here is a three-dimensional model. It will be giving the detailed weathering changes, like the physical and the chemical changes of the composition of the oil fractions can be computed with the help of this model. This one is obtained from DHI. The name of the model is Mike-3 Hydrodynamic Flow Model and Oil Spill Module. So these two models will be coupled together, and then you can estimate the high resolution hydrodynamics and also the change in the physical and chemical characteristics of the oil pollutant. In this one you can see, this is a block diagram. In this one you can see, in this the flow model is having the two modules inbuilt inside. One is a transport module that will compute the change in the temperature and salinity of the ocean water, because they play a vital role. They give rise to the change in the worst meteorological conditions. This is temperature and salinity will be varying. So that contributes to the entire circulation pattern. So that transport module has been considered here, and then a turbulence model, that is which computes the eddy viscosity of the ocean water. We can say the ocean currents. So once after giving all these inputs, this model will be generating the high resolution, three-dimensional currents, hydrodynamic currents, and those will be fed to this oil spill weathering model, which is shown here, wherein here the density of the lighter fraction and the heavier fraction will be given as the initial condition. Initial condition in the sense will be saying that what is the density of the lighter fraction and what is the density of the heavier fraction. So in order to assess all these things, you should have a library of oil. You should have an oil database. From that you can compute this density of lighter and heavier fractions. And by giving the informations like the HM, VM, AM, and WM, those are nothing but the heavy mass, volatile mass, asphaltene, and wax mass. So once after giving all this information, you will be getting the oil track. Along the oil track, you will be getting the mass budget. In the sense, over a period of time, what happens to the mass? There will be a change in the volatile mass. As far as the heavy mass is concerned, it will take a lot of time to undergo the change. And as far as the wax and asphaltene mass, it will not undergo any change because they don't have the characteristics of weathering. Only this light fraction and heavier fraction will be undergoing the weathering. And finally, you can also getting the change in the density of the lighter and heavier fractions. So this model is a very detailed weathering model. And in morning, one of our speaker, Amarnath, was also telling about the computation of mass balance. This model will give you the complete picture of the mass of different fractions of the oil. And this is a typical simulation while generating the high resolution currents of Mahanadi estuary. And here you can see this is the Paradip port, this one. So from this Paradip port, we have a tide gauge installed there, means our INCOIS has installed the tide gauge there. So from that one, we will be getting the surface elevation. So that surface elevation is compared with our simulations. So when an agreement is obtained between the simulation and the observation, we will go for generating these high resolution currents. So here I have taken the vertical section along this line. You can see this one. So here you can see the vertical profile of the currents. So you can see there is a reduction in the magnitude of the current speed as there will be the loss of momentum from the surface to the deep ocean. So that's why here we are observing the lesser magnitude of current speeds while moving towards the depth. And this one is a drift pattern generated from this hypothetical location. These are all the different patterns that are generated with respect to the time. And to have a zoomed version here, you can see in this picture, you can see the oil particles that are, settled, sedimented at different depths. So those things you can see from this picture. So that's what I told, that this model will give the detailed simulation of both the weathering and also the high resolution currents in terms of depth. And from this here also, you can also estimate the change in the mass of heavy and volatile components. And I have estimated the mass balance after running this detailed weathering model. After that, there are several other models are also there in the scientific market, like this METSLIC. METSLIC is a well-known model. It's a three-dimensional which can give both the trajectory and the fate. That's the weathering characteristics also will be computed from this METSLIC model. Apart from that, open drift, open oil, and then NOVA's web genome is there, PyGenome is there. So there are other models like oil map. Several models are there. Only you need to select your purpose. What is the purpose of your simulation? You need to finalize that, and you can go for that particular model. So I have come to the last part of my presentation. This is about the next generation research in oil spill trajectory prediction and the generation of geographical response plan. First thing, we'll be generating an impact chart. Like earlier, there was a discussion in the previous session, like for generating the contingency plan, you can do the estimation. I mean, you can estimate the impacts for a particular season or for a particular month. You can estimate. Here, I have done this for an entire year, from January to December for this calendar year. I have taken the spring and neap tide days, because during that particular time, the magnitude of that currents will be more. So hence, I have selected the spring and neap tide time. And then here you can see this is the region of interest. You can take, you can fix the region of your interest. Suppose if you are coming across the spill, oil spill prone zones, you can mark it like this. And then from this, if any accidental spill occurs, how it can affect your region of interest. So in that way, you can do the simulations with respect to each and every month, and you can determine that after if the spill occurs from the particular location, then during the 36th hour, it can reach the region of interest, or during the every season. And here is our another extended research where this was done during this Mauritius oil spill, where our simulated drift patterns were compared with, again with this Sentinel data that is obtained on August 2020. Once after getting the agreement, the oil drift patterns were superimposed on the eco-sensitive parameters. Here, the coral reef environments are the eco-sensitive parameters which we have considered. And from this experiment, you can see on 8th of August, the oil spillage has greatly affected these reef flats. So from this study, you will come to know at this particular time, if the spill occurs over a particular time, then this is the region that is going to get highly affected, and how much quantity also you can estimate with the help of this study. These results were scientifically accepted and published in the Journal of Earth Sciences. You can refer this complete paper in that journal. And now moving forward to generate the vulnerability and geographical response plans, we are in the way to add the layers, like several layers like potential fishing zone advisories, and then these geomorphological classes, and also the eco-sensitive species over the entire Indian coast. First, those layers will be added, and along with that, the oil drift pattern also will be added. And not only that, we'll be doing the vulnerability mapping. The vulnerability mapping in the sense, in the particular zone, we'll be identifying the sources, the highly prone, oil spill prone zones, where the spill can occur, like wherever if you are finding the SPMs or rigs. So such regions will be identified, and they will be given the rating from 1 to 5. So whichever is getting the higher rating, so that will be mentioned in different color codes, and the number 1 will be given for, red color will be given for the highest vulnerable zone. And then in this geographical response plan, we'll be including that vulnerability map also. And then the other response strategies also will be included in this one. Since actually, based on the request from our sister concerns, we are doing this additional study, wherein you will be, you will be getting the entire picture. Like suppose if a spill occurred over a period of time, then how much quantity is remaining in the ocean, how much is beached, how much is evaporated. So all these estimates will be given with the help of this GRP, that is a geographical response plan. So we are very keen in this, and then we are moving fast also in this. Once after getting the integration, we'll be soon giving this service to all our users. This can greatly help in taking the decisions, and you can plan the response operations also. And here are the list of my publications and reports which you can refer. It will be available in the internet also. So many of our research are scientifically accepted in many scientific journals, and those can be taken as a reference. So with this, I conclude my presentation. If there are queries, I am glad to answer. By the way, I thank the organizers of this Oil Spill India 2022. Especially, I want to thank the organizers, Mr. Abhishek, Mr. Sunny, and the chairman of that. And we'll be glad to support you in future also. Thank you all.
Oil Spill India 2022 is dedicated to the Honorable Prime Minister's Swachh Bharat Abhiyan and Clean Seas.